Good morning, good evening, good afternoon. Thank you, everybody, for joining. Welcome to another exciting stream here on OpenShift TV. We are live streaming to Twitch, YouTube Live, and Facebook Live. If you have any questions, please feel free to drop them in the chat. I am joined today by two fellow Red Hatters, Anand and Arvind. Anand, why don't you go ahead and introduce yourself?
Sure. Thanks, Chris. Good morning, good afternoon, good evening, everyone, where you are. Thanks for joining us this afternoon. And my name is Anand. I'm a product manager with Red Hat OpenShift. And over to you, Arvind.
Hey, folks. Thanks for listening in. My name is Arvind. I'm a principal engineer at Red Hat, leading the Windows container effort. Back to you, Anand.
So just real quick, sorry, I forgot to completely forgot to introduce myself. I am Chris Short, Principal Technical Marketing Manager at Red Hat. Yes, I frequently forget to introduce myself. Sorry. Anand, please, we are doing what today? It looks
Awesome.
fun.
Yeah, thanks, Chris. I'm really hoping this is going to be fun. So today we're going to be talking about Windows containers in a OpenShift world. As you know, during the Red Hat Virtual Summit sometime in April, we went dev preview with this piece of technology, which means you will be able to join Windows nodes to an existing OpenShift cluster. And in this demo, we're going to talk about the architecture, the mechanics, and do a demo of how you can actually join a Windows node to an OpenShift cluster, how to deploy workloads on the Windows node. And then we will look at something called the Windows operator, right? So as you know, everything in OpenShift is about an operator. Any piece of software you got to install on top of OpenShift, like if you have to install Kafka or Redis or even MySQL, any piece of software that you got to install on top of OpenShift, we are based on an operator-based model, and Windows is going to use that same framework as well. So Arvind is going to talk about how you can use a operator-based approach to getting Windows nodes set up, configured, and installed on OpenShift in the future. And after that, we will talk about roadmaps. What are some of the exciting things coming towards the end of this year? Windows containers and Kubernetes in general is an emerging technology. There is a lot of interest out there. There's a lot of demand out there. We see a lot of customers, especially in financial services, especially in healthcare, who want to containerize some of their older legacy Windows applications, lift and shift it to OpenShift. And so there's really a lot of great pent-up demand for it. And so we want to talk about what's the roadmap that customers can avail of. What's some of the options they will have for let's say plugging in storage for monitoring their cluster and so on and so forth. So we will end the conversation with a discussion on the futures and roadmaps of containers in a OpenShift world.
Awesome. Sounds like a great discussion. So let's get it started. Let's dive into this head first.
Awesome. Thanks, Chris. So I want to start with the architecture and tell you the lay of the land. So first of all, here is Chris, let me know if you can see this. So here is the high level 50,000 feet view of the architecture, right? So OpenShift cluster, a basic one consists of 3 masters and 3 nodes, and all these nodes are predominantly based on RHEL Core OS, right? And so if you want to deploy, let's say Linux, your regular Linux containers, let's say you have MySQL containerized in a Linux container, you want to deploy that OpenShift, you can do that pretty easily, straightforward. Now, let's say you have a .NET Core application that also runs on Linux. Again, pretty straightforward, right? Drop the .NET Core application in a Linux-based container, drop it on OpenShift that's running RHEL Core OS, so your application should work fine.
Yep.
Now, the question is, if you have legacy Windows applications, right? Let's say you have a very old version of ASP.NET, or let's say you have an old version of IIS. I mean, there's still guys out there, Chris, with Windows.
My last job before like transitioning to where I am now here at Red Hat, it was working with a very old .NET application that was being modernized. So I feel this pain of having an old .NET application on a Windows server somewhere that I need to modernize. I feel this pain. I've lived this pain.
Yeah, and like you, Chris, I mean, there are, like I said, hundreds, if not thousands of customers, especially in healthcare and banking, who are really desperately looking for a way to modernize and I guess re-architect some of their older Windows-based solutions, either directly into Linux or at least have a pathway into the container-based world, and I guess absorb all the goodness that Kubernetes and OpenShift has to offer.
And just easing that management plane is the biggest thing, right? Like if I want to be able to manage Windows workloads, I want to be able to manage Windows workloads, right? Like I don't want to have a thing over here to manage Windows stuff and a thing over there to manage, Linux stuff. I want one thing, right? Like that's the big thing.
Absolutely. I think you hit the nail on the head. It's, a universal control plane to manage Windows VMs, Windows containers, Linux VMs, Linux containers in, a single, pane of glass. So it's easy to, patch, it's easy to upgrade, it's easy to, apply policies. And, we'll talk a little bit about hybrid clusters in the future, but if you have these hybrid clusters, running, in, several different pockets, it's easy to bring them all into a fold under the umbrella of, things like Rackham and things like that. But you're right. I mean, we need a single pane of glass. We need the universal control plane, which can aggregate these different compute resources, like running on different platforms, onto a single pane of glass.
Mm-hmm.
And so that's essentially what we're trying to do with Windows containers. So if you have some of those legacy applications, we want to help you containerize them. Drop it into a Windows traditional .NET. If you have a traditional .NET framework application, drop it into a Windows container. And run it on a Windows server, which will be running inside OpenShift, right? So you can now have the concept of what we call mixed mode containers, right? Linux containers running side by side with Windows containers, talking to each other. So if you could have a front-end microservice running on Linux, talking to a back-end microservice running on .NET, or the other way around, right?
Yep.
And to round this conversation, I mean, we have an exciting piece of technology that I also believe is in preview. That's called container native virtualization, right? So for those customers who don't want to containerize but still want to path into OpenShift, we do offer CNV, which is a derivative of the open source upstream KubeVirt. So without containerizing, without changing a line of code in their application, without really breaking apart the Windows server, they can pretty much forklift their on-prem Windows VMs into the CNV technology, also running on OpenShift, right? So that is that single pane of glass. So irrespective of where you are in your modernization journey, if you're cloud native, if you understand Linux very well, you want to do Linux containers, we got a solution for that. You are in the containerization journey, but you're on Windows, you want to refactor, re-architect, you can go with the Windows container route. Or if you just want to do a simple lift and shift, you want to preserve your existing legacy investments in Windows, and you want to set yourself up for refactoring in the future, you can always just do a simple forklift. So, the Gartner's 5 R's, right? Rehost, refactor, redo, whatever, right?
Yeah.
So those 5 R's kind of fit into this picture.
Yeah, and I think it's important to point out that you can do each phase of those with OpenShift, and it's something that I've had to do in worlds where the 5 R's didn't exist, right? Like where I had to convince people that AWS's best practices of not doing a refactor and a move at the same time is wise, right? Like you do one first and then do the other, right? You don't do them both the exact same time. So it's good to find that OpenShift can kind of help you on every step of that way.
Correct. That's a great point, Chris, because you do move in lockstep, right? So, I think you correctly hit the nail on the head again. So in the Gartner's 5R, you don't move from, step A to step, A+5 in one shot.
Mm-hmm.
Step A+1. So if you have an older Windows application, you can start by just forklifting it into CNV, step 1. Step 2, containerize it to, Windows-based containers. Step 3, move to Linux containers. So you have a clear pathway towards, cloud native, adoption, regardless of, where you are in the journey.
Absolutely. There's a question in chat. Is there a link to the slide deck? I will get the slide deck out to y'all at some point in time during this presentation, or hopefully shortly thereafter. So yeah, I see this being helpful for people explaining the concepts for sure.
Very cool. So now, Chris, let's get into the the mechanics and the what should I say, the hands-on way. So Arvind, the architect of all this, and what I should really say, the brains behind the magic, right? So what we've been able to do, Arvind and team, is at the core of this project is something called a WMCB, right? And WMCB is really the engine that's driving the bootstrapping of the Windows node into the OpenShift cluster. And it preps the Windows VM before it bootstraps, right? So things like laying out the kubelet, setting up CNI, setting up kube proxy, setting up hybrid overlay. And again, one thing to note is the default OpenShift cluster comes with OpenShift SDN, but to
Right.
activate, the networking for Windows, we need to carve out a certain network space for Windows, and that's where we go with OVN hybrid. And so the WMCP will set up the OVN hybrid network on the Windows VM to ensure that it can, communicate with other Linux VMs in the same cluster.
Ooh, that must have been a tough one to set up.
Yeah, so it's yeah, so this is based on an Ansible playbook that you run through a Bastion host, and we're going to go through that. But the Ansible playbook, couple thousands of lines of code, I can imagine, basically preps this VM and bootstrap to the cluster.
Wow.
And Arvind is going to talk about how this playbook is moving to an operator-based model in the future, because operator will help you manage the lifecycle of the Windows VM in a much better way, consistent with the way we manage Linux nodes in OpenShift cluster, right? So the dev preview goes out with the playbook, and the demo we're going to be doing today will use the playbook, but we're moving to an operator-based approach, which should greatly simplify life for all users.
Out of curiosity, are you going to take the Ansible playbook and turn it into an operator, or are we refactoring the Ansible playbook?
We did think about taking the Ansible playbook and making an Ansible operator out of it, but we did a little bit of research, and we just found that writing a operator from scratch is actually much easier and sort of fits in better with the rest of the existing architecture that we have in OpenShift. So this is going to be a playbook, not a playbook, but an operator written in Go.
Wow, awesome! That's cool.
Cool. Any more questions, Chris, from the chat?
Let's see. No questions. There is a comment about .NET API port. It's a tool from Microsoft's API port on GitHub. Is a free tool to assess legacy .NET framework apps to .NET Core. Oh, cool. That's awesome. Have we figured out Windows authentication? JP Dade, can you elaborate? I'll let him elaborate in chat on the Windows authentication bit, and then let's just keep going. JP Dade, get back to me on that one.
Cool. Yeah. There are a bunch of .NET applications out there. Conversion from .NET Legacy to .NET Core. In fact, I came across one a couple of years ago. I don't know how relevant it is today. It's called image to Docker, right? So people can take like a Windows or a Linux VM, run the tool, and it'll spit out like a Docker file, right? And there are multiple open source tools, multiple community tools, multiple tools put out by indie developers to take older applications. I'm sure they exist on the Linux side as well. To scan what's in the VM or the bare metal and spit out like a Docker file or a Docker Compose file. Yeah, so a lot of projects out there, but I'll look at the .NET Port one. Seems pretty interesting.
Yeah, interesting. I didn't know about that one. Thank you. Hit the fairway.
Awesome. So let's get into the demo. Are we ready for the demo, Chris?
Yeah, let's rip. Let's let it rip, man.
Awesome. So what I'm going to show you now is a demo of bootstrapping a Windows node into an OpenShift cluster, deploying a real life workload onto the Windows node, and also deploying a real life workload onto a Linux node on the same cluster. And we will see how it all lives in a happy union. So here is my OpenShift cluster. So if I say OC get nodes, you should see a basic install of OpenShift with 3 masters and 3 nodes. Now, if I say OC get nodes wide, I should get the exact operating system and the kernel version that's running the masters and the workers. Let's look at the workers. As you can see, it's all based on RHEL Core OS, and the kernel version is 4.18. And so we have 3 worker nodes that are based on Linux, and soon we're going to bootstrap a Windows node into it that's going to be based on Windows Server 2019. So the first step with that approach is going to be to actually have a Windows VM, running someplace, right? So this, Windows VM can be running on your bare metal. It can be running on Azure. It can be running on AWS. It could be running on vSphere. It, doesn't really matter. Let's, go, grab a Windows VM. In this example, I'm going to show you how you can grab a Windows VM, from Azure, because this demo is set up to run on Azure. So let's start with that. So go to Azure. Let's search the marketplace. Say Windows Server Data Center. containers. So this should give you the Windows Server image that has containers, built into it. And this is the version you got to choose, Windows Server 2019 Data Center, and you say create. Now, in terms of the resource group, what I generally do is, since I already have an OpenShift cluster on Azure, I put the VM in the same resource group. I mean, it's just me, just for simple management.
Sure.
I would give it any name. So, Chris, let's call it OCP Windows.
Sounds good to me.
Which?
Even better.
Let's go with that. OCP Windows Twitch demo. That's the name of Windows.
That's going to be a name for sure, I feel like. Yeah.
Awesome. Let's choose Central US because, most of the times sometimes when I choose US West and West 2, especially on weekdays, early weekdays, Monday mornings like this, it, runs out of capacity. So I like to choose Central US. That's the region. In terms of image, we already have it specified. Do we want a spot instance? No, we don't want a spot instance. Yeah, the basic DS2 video configuration is good. Now let's go set up the user credentials for our Windows VM. Awesome. Do we want public inbound ports? Not really, because what we're going to do is we're going to schedule a pod on the VM, but the pod is going to be exposed as a service, and OpenShift is going to provide a cluster IP for the service, so that should let traffic in. So don't really need a public inbound port per se. Do we have a license? No, it's a demo. We don't care about licenses. Disks, just go with premium SSD. You can choose. I think there are multiple other options like Ultra SSD. We have run into issues where if you want to, let's say, have 4,000 nodes of OpenShift cluster on Azure, you may have to choose something like Ultra SSD for improved HCD performance, and HCD is key value store. But we're not going to run 4,000 nodes in this demo, so premium. Yeah, so premium SSD should be good. Let's go to networking. That's really the key, right? So what we need to make sure is this Windows VM that we are bootstrapping is in the same VNet as the rest of the OpenShift cluster. It just simplifies networking. It also needs to be in the same subnet as the worker nodes. We can make sure it gets a new public IP. We do need to put it behind the load balancer. Let's use Azure Load Balancer.
Sure.
Let's choose the default backend pool. We should be good. So this basically makes sure that this Windows node is in the same resource group, the same network security group, the same VNet, and the same subnet as the worker node pool, just to really simplify networking, right? Just to keep it all flat, keep it all simple, happy path. We're going to test it out.
Okay.
Management, things like, hey, do you need to enable, security and monitoring and integrate with AD and things like that? I'm going to pass. Tags, let's set up some tags on this one. Okay. And then make sure it all looks good. So go ahead and review it. Make sure that you look at the rates. So if everything looks good, what you can actually do is go ahead and hit create. This should take a couple of minutes to get set up. You can watch the status of the deployment here. And once the Windows VM is up, we should have a public IP and a private IP. And what we'll then do is we will go to the Bastion host. In my case, it's a simple Linux-based Bastion host. We will download the Ansible playbook, and we will run the Ansible playbook from the Linux host, Linux Bastion. That should really bootstrap the Windows VM, set it up, and then join it through kubeadm to the OCP cluster.
Okay. Cool. So some questions here in chat if you want to go ahead and field some. The so it is a legit Windows box, right? Like it's going to run IIS, right? So if I needed authentication, it's going to be available there. Like you just went through the process, so you skipped over it, but if you needed to integrate with your AD, you could do it right there, correct?
Absolutely.
Is there? Yeah. So I think that answers that question. If it doesn't, let me know, folks. Will we get the same cluster managed upgrades that we enjoy with Red Hat Core OS?
Yeah. So That's a great question, and I'll let Arvind elaborate on some of the details. But the answer is really yes and no, right? Yes, because we will help you upgrade some aspects of the Windows node. So, for instance, all the binaries that Red Hat laid down, right?
Mhm.
Back to this window. So all the binaries that Red Hat laid down, that again comes from upstream, right? Like the kubelet, the OBN hybrid, kube proxy and whatnot. Any CVE fixes, um, any operator specific code that needs to be upgraded, we will go ahead and upgrade it for you. No issues there. But if there are any Windows specific patches, if there are any Windows, security fixes and that needs a reboot, that's not something that we can do, right? I mean, it kind of falls in the, what should Red Hat do versus what Microsoft should do. So the approach,
Right.
so the approach we've taken is anything that the operator lays down, anything that the Ansible book lays down, we will go ahead and upgrade and manage those components. Anything that falls outside that, like a Windows image security patch, right? That's something that you have to work with Microsoft to download and apply and reboot if that
Which,
requires it.
yeah, which kind of ties into the next question. Is there a S2I like tool for Windows containers? And I think the short answer is not yet. Or
I don't know what SQI is, honestly. What is it?
source to image. So you would say, all right, here's my, well, I guess that would work with Windows containers. You just have to change the destination, maybe. I think I would have to tinker with that one. But the idea is that you would just say, here's a GitHub repo, spit out resulting, uh, container, right? Like your repo has a Docker file. The Docker file would point to a Windows container. I'm assuming it would just build that and run it if a Windows host was available. Not sure, to be honest with you.
Yeah, I don't think we're going to support that, at least to start
Initially,
with.
right? Yeah.
It's definitely on our roadmap, but it's not something we're going to target from the get-go.
Okay, makes sense. Thank you.
Yeah, and the other point is with RHEL Core OS, I mean, it's based on RPM, tree, and it's very easily upgradable. We completely own it and manage the entire life cycle of RHEL Core OS.
Mm-hmm.
It's very atomic in the sense we can deliver fixes faster, upgrade it faster. Unfortunately, Windows is way bigger than RHEL Core OS, and it doesn't quite follow the RPM OS tree structure of
It's been around a little bit longer.
Yeah, let's say 25, 30 years.
Yeah.
But yeah, I mean, and it's something that Microsoft owns, right? And so we have to partner with them closely to find out an efficient way to deliver those upgrades to you.
Right. Yeah. So I mean, all of this is tech preview. This is hot new technology. I mean, this is not even fully baked, essentially out to the wild yet, right? Like it's something that you have to enable right now. So obviously there's going to be some features that we would like to have that aren't going to be available in this demo. So just a caveat there for everybody. I see that the box is up. That was actually faster than I was expecting.
Correct. Yeah, it's sometimes Windows takes about 5 minutes, but this time I think it went through fast.
Yeah.
Maybe because it was US Central. So now let's go to the VM and get its public IP address. So those are the three masters, the three workers, the OCP Twitch Windows demo. That's our VM. That's a public IP address we need. Should be getting a private IP address as well. But in the meantime, let's actually go connect to the Windows VM. So once the Windows VM is up, we need to do a bunch of things, right? We need to enable console logs. We need to disable firewalls, if any, and we need to enable it to receive an Ansible connection. So we need to enable the Ansible connection on the Windows server. So let's go ahead and set those things up. Luckily, Arvind has written scripts for that. Get into my Windows machine.
So while this is logging in, one thing I learned is that if you want in RDP, if you want the sound card to actually work, you have to, that's a setting you have to turn on in RDP. So for those of you out there in Windows land that are like, I never have sound on my Windows VMs, it's actually because there's a setting that you have to turn on. Did not know that about the RDP client until recently.
Interesting, but trust me, I'm not going to play any YouTube video from inside.
No, I didn't think you were, but I'm trying to fill the dead air here as we pick networks and such.
I'll be happy if I can, get a web server launched inside the Windows VM and have a pod schedule. That's what we're gonna do.
That's the goal here.
So let me keeps going back to my. I need to copy the Windows the scripts to initialize the Windows VM. So get that.
Arvin, you posted the link to the GitHub page, right?
Yes, I did.
Thank you.
Yeah, at Red Hat, everything is open source, so it's all out there.
Yep. Good, bad, and ugly.
Yep.
So let's go launch PowerShell on Windows. Let's run the first script, which is to enable the Windows server to receive an Ansible connection. And Arvind, I'm assuming all this is going to be simplified by the time the operator is in, right?
It's going to be definitely way, way more simpler.
Okay, good.
Yeah.
So the idea behind the operator, Arvind, would be to do what? Like, what would the operator be doing in this case?
So what we're trying to really do is try and make managing a Windows node, a Windows worker node, as easy as it is to manage a Linux worker on an OpenShift cluster. So, for example, if a customer wants to add another Windows node or a Linux node, they're going to create a Windows machine set or a machine set object, and at the end of creating that machine set, you have a new Linux worker added to the node or added to the cluster. We are going to follow the same pattern there. The customer will come, create a new machine set, but in the configuration, they will specify a Windows image. And as a result of that, you're going to end up with a Windows machine, and what the operator is, which is going to be watching for such machines, is going to get involved and say, hey, this is a Windows machine. I know how to set this guy up. And it's going to do all the configuration needed, installing the kubelet, installing any CNI plugins that are needed.
Right.
And at the end of it, you're just going to have a Windows node all ready for you to put your Windows workloads on.
Yeah. So the operator pattern, I think, is very powerful here and helps us achieve the kind of push button experience that people are wanting, that skips the copy pasta of what we're seeing right now. I feel like not to call copy pasta a bad thing. I think it's awesome that we can give commands to people and it just works most of the time. But the actual ability to add these VMs on the fly, I think, is huge, especially with the machine config operator doing it for us.
That is totally correct. And it's also going to, the way a customer is going to use it, right? We're going to onboard this onto Operator Hub, which is present on every OpenShift cluster. So it's going to be like any day two operation that the customer would want to do. They would go to Operator Hub. There would be a Windows machine config operator. They would install that Windows machine config operator, give some kind of private key that needs to be used to access the Windows VM. And that's about it. After that, they just go and create a Windows machine set and walk away.
Yep.
They have to do no other manual steps. And because we're using Operator Hub, we are leveraging the Operator Lifecycle Manager. So if there's a kubelet issue or a kubelet CVE that needs to be fixed, we'll release a new version of the operator. The operator will get upgraded on the cluster.
Yep.
And when this upgraded operator comes, it's going to say, hey, I see all these worker nodes that have not been updated. I'm going to go and update all of them. So we're going to follow the same operator updating its operand pattern with our operator. So it's going to make things very much
easier. Much easier. Anand, what you get cooked up here for us?
Awesome. So while Arvind was explaining the operator, what I did was a couple of things. One was I went and enabled network security group rules to make sure that the Fedora, the Linux host, the Linux bastion can communicate out with the Windows node. So essentially, both of them are in the same VNet, but the Windows VM needs to let traffic through the WinRMS HTTPS port.
Mm-hmm.
So I went to the network security group in Azure, and I made sure that there is an inbound security rule that says for the Windows host, let traffic in only from the Linux bastion through this port, right?
Nice.
And I did a ping test, and that seems to go through fine, which means now if we go back to this diagram,
should work in theory.
connection should work, and this should be able to communicate out of the Windows node and set up all the networking infrastructure and the other plumbing infrastructure for the Windows node to be able to participate in the cluster. So what we're going to do next is we're going to do the bootstrapping through the playbook, and this really is the core of the whole feature, right? It's it's what the feature is all about. And assuming the playbook takes about 5 to 10 minutes, maybe shorter to execute, we should be on our way to deploying our first production workload, our first workload in Windows. So I can't remember command, so sorry about that. I'm going to copy paste the command. So this is the Ansible command that we need to run. Oh, sorry, this is the one we need to run.
There you go.
Yeah. Chrome keeps getting me back to a different window.
There.
And that's the WMCB that we'll be talking about.
Mm-hmm.
And I press enter. This should take somewhere between 5 to 10 minutes, depending on the speed. But as you can see, it it lays on the kube proxy, installs.
Yeah, CNI plugins, the whole 9 yards. Yeah. Wow.
Yeah.
Moving right along though.
Yeah, it is, and maybe maybe wait for this, or maybe Arvind can shed some more details on the operator. And
yeah, I can do that. And what you see the playbook doing, the operator is going to pretty much do all of that. But the key bit that Anand spoke about, which is the Windows machine config bootstrapper, which Anand referred to as the engine, that's going to still be there. It's just that the operator is going to be the one driving that engine when we go GA. That's going to be the key difference. And as you can see, right, there's a lot of manual steps involved here. We are trying to help customers not have to deal with the manual work involved. And that's going to be the key differentiation with the operator model. And I remember someone was asking questions on chat about upgrades. We are going to do upgrades of all the Kubernetes components that's running inside the node.
Right.
We're not going to take care of the Windows updates, but the customer still has a way to get that in. Say, for example, there was an update for a particular version of Windows. If they want to grab that update, all they have to do is specify a Windows image in the machine set with that new image, which has the updates installed, and the operator will take care of making sure that the new Windows VM that comes up, has been configured to run as a worker node. So we indirectly do help out in that case, but like Anand said.
But we're not going to make that decision for you, right? Like that's Windows updates are a thing that organizations have to determine when it's safe to apply for them, and we're not going to automatically do that for anybody, because that is just whoa. JP Dade, Windows operators will GA in 4.6. It is currently tech preview. Hit the fairway. How does the workload get tagged to run on the Windows box, or does it automatically identify it as a Windows container?
So there is no magic there. Every Windows node is going to have a taint. And when you create your deployment, you are going to say that, hey, I need to tolerate this taint, which sort of indicates that it's a Windows workload.
Yeah, so back to the taints and toleration stream we had a little while back.
We can also use runtime classes, which is what SIG Windows is suggesting people do if they want to have disparate Windows workloads and disparate Windows nodes, and so that they can have some sort of matching based on what server version of Windows you're using. So
interesting. Okay.
runtime classes is the other option.
Okay. Cool. Let's see. Back to chat.
By the time we move to the operator-based model, so just rounding off what you're saying, so users should be able to come into OpenShift, get into the operator hub, look at installed operators, search for, I guess, the Windows operator. Is that how we're going to call it? And then
it'll be the Windows machine config operator. Yeah.
Cool. And then we provide them steps to install it, through OpenShift. So they will have to go through, all the steps of getting a Bastion, running the playbook. All that's going to be cut short for them, right?
That is correct. Yes.
Is there support for user provisioned infrastructure like existing VMware clusters that don't use machine sets?
So with the first release, we're not going to tackle that problem, but it's on our roadmap.
Cool. Thank you.
Yeah, and vSphere in general, Chris, just to elaborate on that, customer ask, I think it's a very valid one. And we've been seeing a lot of customer demands around trying to run Windows nodes on vSphere, because if you look at VMware, they have a pretty good install base on x86, right? I don't know the number, but it's like 80% of all x86 servers have VMware to that number, and a lot of them are running Windows workloads, right? A lot of the on-prem workloads that are running Windows are locked in vSphere, and we understand it is a very critical platform for on-prem customers who want to move their Windows VMs into containers. So like Arvind said, that's not something that we will likely to get to in by GA, but that is definitely something that's very high up in our roadmap.
Cool. Very high up in the roadmap. I like that. It's important. Very important. All right. How's it going here? Uh-oh.
Yes, I think it's done. I see a few failures, but I don't think that's any cause for concern. I think they're just some
timeout, looks like, yeah.
Logging issues. So I'm just going to say OC get nodes. Oops, I do not see the Windows node in here.
Okay.
Let's see what happened.
Looks like the demo gods are not happy today.
Uh-oh. It was fast at first. I said something to frustrate them.
So it looks like the CSR got approved. There's something went wrong in trying to get the bootstrap node name. I do see, when you did OC get nodes, I did see a OCP. No, I did not see it. Okay.
Okay. So it looks, it couldn't find the private IP, it looks like. Is that the right private IP? I don't want to ask a stupid question, but.
This is the private IP.
Yeah. So.
But, when we did the ping test, right? So when we did this ping test, we used the private IP, and, that went through.
Okay. So yeah. I mean, it worked. It just couldn't hawk it for some reason. That's weird. What was, can you, here, well, actually, I can read the playbook myself. Hang on. I'm Ansible certified. I know what's going on here. Let's see.
Yeah, it's basically, so on, I don't know whether we want to, sort of debug this, but if you do OC get CSRs, it should tell us if it's just CSR, no.
Yep.
That's kind of interesting.
Huh, approved and issued.
Yeah, so it bootstrapped correctly, but the second CSR did not show up for some reason, is what I'm guessing happened.
Maybe it didn't show up in time.
Possible.
Yeah. So one thing I can do is, luckily I have another Windows node, and I can try to bootstrap that. So give me 1 second. So we'll give this one more shot and see if demo gods can be pleased. This app. I'm gonna go. Let's see.
I like to remind folks that failure is an option on this channel. the demo gods. There's infinite number of services and latencies and interconnects that are involved in these. So, if Ansible playbook fails in the dark or in the woods, does anyone hear it? Yes, on this channel. But is it perceived negatively? No. Everybody, I think, watching understands that this stuff is hard.
Yeah, so I'm going to try with a different Windows host.
Okay.
Luckily, I have one more. Let's see if I can bootstrap that into a cluster. Yeah, so I'm able to ping to it. Again, I'm using the private IP. Now let's make sure I can bootstrap that. If not, there's probably a bigger problem with, or another problem with issuing CSRs on this specific cluster. So let's give it a shot. Oops, I ran the same command again.
So while Anand is doing that, I will answer someone's question about vSphere not being there or VMware not being there in 4.6. We are trying to add support for installer provisioned infrastructure in 4.6 with vSphere. We just will not be able to get to user provisioned in 4.6.
And if people don't understand the difference that are watching, user provision infrastructure is where it's like bringing your own infrastructure. The IPI installers, the infrastructure provision installer, or the installer provision installer, I think is how somebody referred to it. Like it basically says, all right, it takes in some parameters. I want 6 Windows nodes. Off I go. Yeah, like that's the IPI install experience where you just kind of tell it, I want it to deploy here. I want to have this many nodes of this type, and off it goes, kind of thing. That experience is not necessarily easier to build, but it's more rigid, I guess, right? Like it's easier to predict the IPI installs always because we're the ones building them. Just as long as we are smart about it, it should be pretty simple to go from there to a UPI kind of experience, minus the hurdle here or there.
Yeah, that's pretty much true. And so even with vSphere, if it's IPI, all the customer has to do is in the machine set specify the Windows image as part of the machine set configuration, and the operator will take care of the rest.
Yeah. Grabbing the Q config.
Yeah. So as the playbook is running here, the other try is Arvind luckily has a cluster that's already built out. So I'm just exporting the kube config for that. So in case that Ansible playbook plays again, luckily we already have a cluster that's built out. So it should be good.
Okay.
Let's give this a few minutes. Let's see how it works out. Kube config to Arvind's cluster, and then we'll deploy like a production workload, a Windows workload on that cluster. So
it's like a cooking show sometimes. Kind of have to be ready for anything.
Yeah.
Yeah. So if you're not familiar with Ansible, Ansible has the ability to retry, and you can specify the number of times and any number of links you wish as variables in your playbooks as you see fit. So if you have like a long running operation like a reboot, or in this case issuing a CSR because there's compute to generate keys involved, it's good to throw in a retry or two as you're waiting for that step to be finished, because the default, I think, for Ansible is like 15 seconds or something like that. Something reasonable but short. don't know if it's going to work. Why don't we try left? It's like, ooh.
Yeah, I'm not so hopeful. Usually it doesn't even,
Yeah,
the
usually
CSR
should
shows up
just
pretty
happen.
quickly.
Yeah. I mean, these aren't like lightweight nodes you're using. So, yeah.
Yeah, let's give it a minute. If not, I'll switch to cluster that already has the Windows node on it. So,
Yeah, things break. Yeah. Looking.
any other questions on the chat, Chris, in the meantime?
No, just a lot of praise, basically. JP Dad says, love it when it fails for the experts. I do not feel so bad when it fails for me. JP Date also loves Ansible and appreciates all the work we're doing here and likes live demos as well.
No problem.
Already got the machine set question, identification question. If you have a question, please feel free to drop it in the chat. If I haven't gotten to it yet, please hit me over the head with it again. Is this cloud agnostic? Yes, should be. Yeah, that's all the questions.
Yeah, one thing on the cloud agnostic piece is, so as you can tell, the core of the solution is based on a networking plugin called OBN Hybrid, and we're jointly working with Microsoft and making this plugin work across Windows and OpenShift. And so the dependency for this to work on any platform, AWS or Ali Cloud or vSphere, is that OBN Hybrid works on that platform, right? So that's a dependency we have. And I believe OBN Hybrid is going GA in 4.6, and that supports half a dozen or more platforms. So as far as OBN Hybrid is support on that specific cloud provider or that cloud platform, we should theoretically work without any issues.
Yeah, theoretically.
Yeah.
Kubernetes networking and all.
So while this is coming up, I'm actually going to just maybe point to Arvind's cluster already.
Yeah, I think it might be time.
Shot. Oh, this progressed. I think this time it's going to work. So I think we may be able to use this cluster itself. So let's give it a minute. Sorry, Chris.
No worries. No worries.
Going back to original approach. Let's see. I'm a little more positive this time because I think it's progressed a little more.
Right. Yeah.
Yeah, it's gotten to the CNI configuration stage.
So yeah, clearly it's got something right.
Yeah.
True exists. Wow. Okay. Here we
That's
go.
the other big difference you have with Windows worker nodes is you always need to have qproxy running if you want to do any sort of north-south communication, which is slightly different from Linux.
Awesome.
And that looks like success.
Wow. Okay. Good job.
Cool. So we have our Windows OCP node on the cluster. I can say OC get node. Again, one thing to point out, Chris, is this is a pre-existing Windows VM I had, not the Twitch demo one, because
right. Yeah. No worries.
So now the key is, as you can see, the three masters, the initial three workers were based on RHEL Core OS, but this new worker node is based on Windows Server 2019. I know the text wraps is difficult to read, but it's Windows Server 2019 with a kernel version of 10.0.x. So that's that.
Where does that version number come from? Is that the actual OS version?
That's the actual OS version, yes.
Okay. Interesting. Okay.
Yeah. The other thing is, I think there was a question about, how does the Windows container get placed on the cluster? And I think Arvind hit it right when he said it's based on, taints and tolerations. So
Mhm.
taints is the opposite of affinity, right? So affinity lets nodes attract pods, and taints lets nodes repeal pods, right? And if you want to see a list of all the taints on all the nodes in this cluster, this command will give it to you. So if you look at all the taints on the master's tainted with a key value pair of no effect, because you obviously don't want workloads being placed in the master, right? So the three masters will have taints of no schedule. The three Linux workers, the RHEL Core OS workers should not have any taints. But if you look at the Windows OCP node that we just bootstrap, that has a taint of OS is equal to Windows, right?
Mm.
Now
Yeah,
any
that's nice.
yeah, so any pod now that you schedule on this node should have the corresponding toleration, like Arvind mentioned, with the same key value pair. So what we're now going to do is, luckily, I have such a uh, pod. So it's just a simple Windows web server, as you can see, and there is that corresponding toleration of saying OS is equal to Windows, and the effect is no schedule, which means if it does not match it verbatim, then do
Mhm.
not schedule this pod on any other node, right?
Nice.
And so it's basically a Windows web server based on this running on Windows Server 2019. So let's actually go ahead and without much ado, let's go ahead and deploy the deployment, create the deployment, and then you say OC get deployments. So there is that deployment. Let's say OC get services. Oops.
Oops.
OC get services. As you can see, I just created a service of type win. It's
Okay.
IP depending, so give it a few seconds. It takes a few seconds for the externally provisioned IP to be available. In the meantime, if I say OC get pods, you can see I have that Windows Web Server pod. So
Nice.
back and see OC get services. Again, sometimes it takes longer than a minute. So there we have it.
There you go.
External IP. Now you can go put it inside a browser. :80 if you want to, if you're a stickler for rules, else you don't really need it. And this should bring up the Windows web server.
Cool. So a couple questions here. Arvin answered one. We were working on the must gather. Could this be used to test an app over Windows, like from a Jenkins deployment? Yeah, I guess in theory, if you think your app is ready for Windows or like ready for migration to a Windows container, yeah, you could just slap together a quick Jenkins pipeline and just throw it over on a use the container on a Windows node as opposed to a VM or something.
Yeah, and that's a good question. So, I mean, there are a lot of ways you can do it, Chris. One is you can point your Jenkins pipeline to this cluster. The other way is, a lot of people in the open source community like VS Code,
Mm-hmm.
and VS Code has a Kubernetes tools extension. So you can go install that, and they provide you the exact steps of, hey, what are the dependencies you need? How do you point a cluster like Minikube or OCP to VS Code? And then what you can do is you can make your app in VS Code, and then you can go deploy it from VS Code onto OpenShift using this plugin, right?
Nice.
So that's another way of I guess connecting your okay, so there it is. So we have the Windows.
Oh, beautiful.
Okay, good. I actually want to round up the demo with one more simple thing. Is I want to show a Linux container also deployed on the same cluster without the toleration, and
Okay.
that should work as well. So where is my Nginx YAML? So that's my Nginx YAML. I'm going to pull that down. I'm going to say kubectl apply -f, for an Nginx YAML. So I say OC get deployments. I should have the Nginx deployment. Now I can say OC expose deployment, name of the Nginx deployment, type is equal to so that's exposed. Now if I say OC get services, the Nginx, again, external IP takes about a minute or so.
Mm-hmm.
I'll keep refreshing. In the meantime, you can say OC get pods. Yeah, so it's created like 2 replicas.
Yep.
Yeah, Nginx should give us an IP in a second or so. And once I have that IP again, I'll put inside a browser and
It'll work. Yeah, it should just work. And this is a dependency on Nginx going out and grabbing an IP from Azure, correct?
Correct.
Yeah.
Yeah. Sometimes it takes a minute or so, longer than a minute or so.
Yeah, I mean, it's networking. Who knows? It depends what the load is at that moment. And that's
correct. So this is just an example of, like a mixed mode cluster, right? So going back to, diagram that we saw in the beginning, right? This diagram that we saw in the beginning. So you had an Nginx container run on OpenShift. You had an old, IIS-based web server run on Windows container, also on OpenShift, in the same cluster, in the same control plane, like you were alluding to in the beginning, Chris.
Yeah. Like that is the goal.
Yeah.
Single point of entry, single pane of glass, whatever you want to call it. But management development has the same experience consistently throughout OpenShift, as opposed to throughout different experiences across each cloud or whatever. We forgot the N. The N in Nginx. No.
Okay. It's some cloud provider rate
limit. Rate limited. Ah?
Yeah.
Have you been testing this today?
You've been doing too much on that cluster, Anand.
Yeah, too many services on that, and I've run out of limit. But this is what it is, right? In fact, I can now. We're trying deleting Windows.
Yeah, if you're rate limited, it's not going to go away that easily.
No. Yeah.
You're going to be stuck there for a while.
Yeah. That's going to take some time.
Okay. So once your Azure quotas are in place and your rate limiting APIs are fixed, there is a bump it up, right? You can bump up your rates in Azure, right?
Mm-hmm. Yeah, it's so this is a common problem that if you're using your own cloud, right, for demo purposes that we run into all the time. So I'm not surprised that you're hitting this in the middle of a demo. Yeah. So rate limits in clouds are a thing, sadly.
Correct. So that's, I guess, really the end of the demo here. So we're not able to complete the last piece because of the rate limit, but at least, we saw a Windows node being bootstrapped and you being able to place workloads on the Windows node.
Yeah.
Any other questions, Chris?
No. Let's see. There's a thanks to 1Jan70 for being on the support team. So yeah, thank you a lot for being on Red Hat support. Thank you so much. 1Jan70. There's a script in an Access article. Let me open that up. But yeah, no more questions. Data gathering and events must gather fails. Oh, okay, cool. Yeah, no more questions unless anybody's got some last minute ones. But yeah, if you want to go over the roadmap real quick, I think that'd be helpful for everybody, considering all the questions.
Yeah, I'll spend a minute or so on the roadmap. So what you saw right now was bootstrapping the Windows node. So in 4.6, we will land the operator, like Arvind was saying. We'll support some cloud platforms like AWS, Azure, maybe vSphere if we get to it. We will have some story for monitoring and logging. So you should be able to see Windows event logs in OpenShift for Windows containers. We will have some story for storage. So you should be able to attach some sort of a persistent volume claim to Windows nodes, backed up by, let's say, Azure Disks or Azure Files or whatnot, and be able to mount those PVCs inside the pod, right, inside the Windows pod, to get some persistent storage in Windows containers. So we will deliver that. We will have some story for delivering patches. So again, these are not Windows patches like Arun was saying. These are OpenShift, Windows operator specific patches that we will deliver. So that will basically carry us through GA, and then after GA we will work on things like handling CVE fixes better. So in case there is a CVE fix, on the kubelet, how do we deal with that? We will handle stories like auto scaling. So in case you want to go from let's say 1 node to 4 nodes, if you want to play with the cluster autoscaler to be able to autoscale horizontally, we will have some story for that. We'll have some story for GMSA, some level of performance and scale testing. And in the long term, we want to, obviously, not stars, but we want to support things like Knative. We want to support, ARO, which is, Azure, Red Hat OpenShift. You
Mm-hmm.
want service mesh, and ARO is an interesting story, right? So all the Windows applications that are running on-prem, if you can containerize them, move it to OpenShift, and run ARO on Azure, and that's a perfect hybrid cloud story with Windows and OpenShift and Azure, right?
Yeah.
So
Yeah, that really is. Question in chat: when is 4.5 going GA? I can answer that with the official answer soon. Or, but yeah, this was awesome. I'm sad that we hit a rate limit, but oh well, things happen. If there's no other questions, then we'll just wrap this puppy up. If that's cool with y'all. Yeah, no objections. Any other information we need to pass along to everybody?
No, I think we've given out a lot of information at this point.
Yeah. No, I
feedback.
think, I think feedback is welcome at this point. Feel free to reach out via social media or me directly, cshort@redhat.com, and I can get you in touch with whatever other Windows needs you might have here. And I will be seeing you all a lot tomorrow, I think. Coming up on the channel tomorrow, our developer experience office hours at 11 a.m. Eastern Time, 1500 UTC. Then OpenShift Commons briefing, Big ID, privacy by design, and transforming data risk into business value. And then I think that's it. Yes, I have other meetings that are not live streamed. Sorry, I thought I was busy tomorrow, having multiple streams back to back to back, but I don't. But who knows? There might be one soon. Might be a day like that soon in the very near future. So yeah, stick around. Definitely subscribe to the calendar if you haven't. I just dropped the link to all of that in the chat. And if you are, Ryan, I hope you're on tomorrow at 11. Hope to see you there. But catch us soon on a live streaming platform near you. Thank you so much to Anand and Arvin for coming on and demoing this for us. And I hope you all have a wonderful day, a wonderful week. And the slides. People want links to slides. Anand, Arvin, could one of you send them to me in the next 24 hours so I can distribute them via either OpenShift social media, or I can add them, I think, to the descriptions for sure.
Sure, I can send that to you, Chris.
Yeah, thank you very much. Check the descriptions on the videos once they go final for the slides. That'll probably be the best way to get them. All right. Thank you very much, everyone. Have a wonderful day.
Thank you, folks.